Okay, video solutions for the final test, Unit 1, two-dimensional geometry. We have us with today a special co-star, Wyatt Rooker. Yeah. Okay, so we're going to go through each problem. What you needed to do for your homework is write down the solutions to the problems you got wrong and then bring that back with your test paper so we can go over it together. All right, number 1, it says, which rule describes the translation right 4 units and down 5 units? Well, we know that x comes first, y comes second. We know x is right or left, and y is the up or down. So, if I'm going right 4 units on a number line, that's to the positive direction. So that means I'm taking my x and adding 4. If I'm going down 5 units, we know down on the number line is -6, so I'm taking my y and minusing 5. So the rule is x plus 4, y minus 5. So that's B. Okay, number 2. What translation does the rule xy to x to y plus 5 describe? Well, we know x is your left or your right. And we know y is your up or you're down. All right, well, from our x, we know nothing can happen. It's not going left or right. So we know going to the right and going left are not possible. So now we're either going up or down. Well, we just learned that going down was minus, so going up is positive. So obviously I'm going up, and then it's 5 units. So that's D. Okay, number 3. Describe the rotations in another way. We know going around a circle is 360 degrees. So if I'm going 97 degrees of that, which would be a little bit more than a quarter, so there's 90, and then a little bit more. So that's 97 degrees. I need to know how much more that is. Well, if it's 360 degrees total, and I've used 97 degrees, then what am I going to do, Wyatt? What did I just do here? If it's 360 degrees the whole way and I used up 97, what do I do to find the rest? No, subtract it. I subtract what I do know from what the total is. It's like this, okay? You gave me $60 to hold on for you for a party or something. You used $20. What's left?
40.
Because you subtracted, right? It's the same thing here. So I have 263 degrees, and I'm going this direction, which is counterclockwise. Okay, so Wyatt, I'm going 190 degrees clockwise. What do I do to figure out what I'm going to do to go counterclockwise, which means these two aren't even possible?
To the right.
Well,
Or no, left.
okay, but I don't need to go left or right. I've already explained that. So what do I do mathematically? What did I just do in the one before? Okay, I'll make a circle. So that's 360 degrees, right? Okay, I just went 190 degrees clockwise. So that's actually half of it's 180, and there's about 190. So what do I do mathematically to figure out, go in the other direction?
Subtract.
Subtract from what?
360.
All right, so 360 minus the 190 degrees clockwise will give me how much I went counterclockwise. All right, name the coordinates of the point after the described rotation. So I'm going to go ahead and make a little coordinate plane. Okay, I did that in our notes, so we have a visual to look at. So I'm right now at -3, +5, so somewhere up here. I'm going 90 degrees counterclockwise. So the first thing we did is which direction? Counterclockwise. How many degrees? 90, so that's one rotation. So I'm going to be right here. So what are my signs going to be, Wyatt, in that quadrant?
Negative.
No.
Negative.
Negative. So right off the bat, not possible, not possible, Not possible. So without even doing the rest of the work, I know it's A. But then our rule states that when I go 90 degrees, I take my numbers and switch them. So it was a 3 and a 5, now it's a 5 and a 3. And whatever quadrant I'm in, that's the sign I'm going to use. So it would be -5, -3. Okay? So let's do the other one. So here I am at 5, -7. Okay? I'm going half a turn. So if I'm going half a turn, what quadrant does that put me in?
Which way are you?
Half a turn. Doesn't matter. Which quadrant will I be at?
Second.
Okay, so I'm going to be over here. Okay? So we know the signs of those are negative, positive. Right?
Yeah.
Okay, what's our rule when I rotate 180 degrees? What do I do with the coordinates?
Switch it.
I need to switch them.
-5, +7.
I just changed the signs. Very good. So it's going to be, instead of 5, -7, it's going to be a -5 and a +7. So that's letter C. Okay, good job. Okay, number 7. Given the coordinates of the pre-image and the scale factor, find the coordinates. We learned in class that if I know my original point and I know my scale factor, I'm simply going to take and multiply my scale factor by those points. So I have 1/2 times -5, and I'm going to have 1/2 times -8. All right, well, we know that we just do top times top, bottom times bottom, so I have -5 over 2. And in this one, I have -8 over 2. With -5 over 2, it's going to be negative, and 2 goes in there, 2.5. And then -8 over 2, it's going to be -4. So I have -2.5, -4. So that would be the same as -2.5 and -4. So all I do to get my new coordinates when I have a scale factor problem, a dilation, is I just multiply the scale factor by each of the coordinates. Simple. So same thing here. Here's my original point. My scale factor is 3. So what am I going to do to each of these, Wyatt?
Switch them. Just the point.
No, now we're on scale factor.
Oh,
What do I do when I have a scale factor?
times.
Yeah, I'm just going to times. So I'm going to times the x coordinate by 3 to get -9. And then I'm going to multiply the y coordinate times 3 to get 15. So my new coordinates would be -9, +15. That means they're 3 times bigger. So that's letter C. Okay, so if I had a point and I wanted to find the new point, I multiplied by the scale factor. And these two. Here I know both points. So I got to find the scale factor. So let's do the opposite. What's the opposite of multiplying?
Divide.
Dividing. So this time I have a little formula. The scale factor will be the new point over the old point. Okay? So this is actually the prime point over the actual image. All right. So here's our new, here's our old. So we just pick either the x's or the y's, it doesn't matter. So I might as well do the x's. So I have -2, that's our new one, over 6, which is our old one, and then we simplify. So negative over a positive is a,
Negative.
and then 2 over 6 is what? Simplify it.
1/4. No. 2. Yeah, 1/3.
1/3. And there's your scale. Okay, it's going to be 1/3 as small, and it goes in the opposite direction. Okay, number 10, same type of problem. So again, I have my scale factor equals my new coordinate over my old. So I don't like using the 0, so let's go, here's my new y, here's my old y. So Wyatt, what's 12 over 3? 12 over 3, 12 divided by 3, come on, simplify it.
4.
So our scale factor is 4. It's 4 times as big. how many lines of symmetry does the figure have? Okay, well, we can divide it up going this way, right? Or this way, you think? Ah, very good, Wyatt, because these 2 points, these 2 points right here would not make it symmetrical. Only this one going straight down the middle does. So there's only one. Okay, rotational symmetry. Now, when we actually do this for the retest, I'm not going to do this. These should have been taken out because we didn't go over this. Unfortunately, I wasn't here for that, so we'll go over it now. All right, that means I can rotate this. If I take this shape and I rotate it, okay, what I want to know is where does it look the same? So, tell me where it looks exactly the same as it did before. Where does it look exactly the same as it did before?
Now.
All right. In other words, I had to rotate it all the way around 360 degrees, which means it doesn't have any rotational symmetry because I had to bring it back to where it was. So no rotational symmetry. Okay, 13. Name the following pairs of angles. Vertical angles. Well, we know vertical angles are across each other, right?
Yes.
So let's look at 1 and 5. Here's 1, and here's 5. Are they across from each other?
Yes.
They are?
No.
No, across from each other.
That'll be
Kitty
one.
corner.
Yeah.
Okay. 5 and 8. Here's 5, here's 8. Are they
Yes.
across each other? Yes. There's your vertical angles. And we know vertical angles are congruent. They're exactly the same. Okay, alternate exterior angles. We know alternate exterior angles rotate across the transversal, but they're on the outside. So that means that they're here and here. They're on the outside of the parallel lines. So 1 and 5. So here's 1. And here's 5. Are those alternate exterior?
Yes.
No, because the 5 isn't over here. Remember, alternate means that they have to go across
Oh.
the transversal. No, and exterior means that they're on the outside of this. Here's my parallel line. So here's the inside. There's the outside, or exterior. Okay? So 1 and 5 are actually called corresponding. They're in the same place in the intersection. If I brought this thing down and laid it on top of 5, it'd be exactly the same. So 1 and 5 are not in. Okay? 5 and 8. Well, we already know 5 and 8 are called what? What kind of angles are those?
Vertical.
Vertical angles. Good. Okay, 2 and 7.
Yes. Yes.
Yes. We know that alternate exterior angles are congruent. Good. Okay, here we go. 6 and 8. All right, so here's 6. Here's 8. What do we call those? Well, are they vertical angles?
No.
Are they alternate interior angles? Interior means on the inside, and then they would alternate back and forth.
No.
No. Okay? Alternate exterior. That means they have to be in the outside, and then they cross over the...
No.
No, not those either. Okay? Are they adjacent angles?
Yes.
Yes, they share a common side. Good. Okay, 3 and 7. So here's 3, here's 7. Okay, are they vertical angles? Oh, go ahead.
Corresponding.
Yeah, they're corresponding. They're in the same place in the intersection. Good job. Okay, and finally, 2 and 3. You know that.
Or no. Vertical.
All right, vertical angles. They're across from each other. All right, and then lastly, was it numbers 4, or angles 4 and
3.
Angles.
Number 2.
number 18,
4
4,
and 5.
4 and 5?
Yeah.
Okay, so what are those?
Not vertical.
Not vertical.
What's alternate?
Remember, alternate means they cross the transversal, And they're on the inside.
Yes.
Yes, that's what they are. Good. Okay, here we go. Now we just got to do a little work. Okay, translate the figure 5 units left and 3 units up. Determine the ordered pair for C. So I'm going to go ahead and make this just a little bit bigger. All right. So I got to go 5 units left and 3 units up. So here's C, right?
Yeah.
5 units left would be 1, 2, 3, 4, 5.
Negative 1.
So I'm going over here.
Negative 1.
And then 3 units up would bring me 1, 2, 3 right to there, right?
Yeah.
So what point is that? Right here.
Negative 1.
Negative 1.
Negative 3.
No, I'm on the line.
0.
0. Okay?
Okay.
Number 19. 20. Okay, it says, let me go back here. Rotate the figure 90 degrees counterclockwise about the origin and determine the ordered pair for point A. For point A. All right, so 90 degrees counterclockwise. So here's point A. It's over negative 3 and up 2. So we're going counterclockwise. That means they're going this direction. I wonder how many kids did do that, went the other direction. So I know that my sign has to be what? What would my sign have to be?
Negative. Negative.
All right. Okay, when I rotate 90 degrees, what do I do with those coordinates?
Switch them.
Yep, so it'd be a 2 and a 3, and we know they're both
Positive or negative.
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 So it'd be over negative 2, down negative 3. All right? And then what you notice is this distance from here to here is the same distance as from here to here. All right, number 21. Reflect across the y-axis and determine the ordered pair for point B. So reflect across the y-axis. All right, so here's my y-axis right there. So I'm simply going to flip it across there. So I need, which point? B, right? Wasn't it?
Yes.
So here's B. How far is B?
Determine the ordered pair for A prime.
For 21?
Oh, that's sweet.
For B.
B, yeah.
Okay, so here's B. How far away is it from the line of reflection?
2.
So I go 2 on the other side. And there we go. There's B prime.
Negative 2.
So
Negative 3.
no.
Negative
3. Negative 2.
Yeah.
And then the last one.
6.
Okay, it says reflect across x equals 3 and determine A prime. Okay? So x equals 3. So it crosses the x-axis at 3, right?
Yeah.
Okay. So it crosses the x-axis at 3, so that's right here. I wonder if some people went across right there. X equals 3 means it crosses the x-axis at 3. All right. Now let's just count. What was it? A prime again?
A prime.
Okay, so here's A. So how far is it away from here? Not there. So it's 1, 2, 3, 4, 5, 6, 7. So I got to go 7 on this side. 1, 2, 3, 4, 5, 6, 7. And what's the point?
I guess.
10
10.
up
2.
2. And there you go. Good job, Wyatt. You're done.